Another very useful application of histological analysis is assessing age at death. In well-preserved remains, this might not be necessary, but in poorly preserved remains, or in cases when macroscopic features are dubious, histological analysis can help assess the age at death or narrow down the assessed age frame. But first, we need to understand bone growth. Toddlers have primary periosteal cortex that includes transitional fibrolamellar bone with vascularization via primary osteons and scattered simple primary vascular canals, both having a predominantly longitudinal orientation. A concentration of large resorption base can be observed near the endosteal-periosteal boundary. Children have primary periosteal cortex that is lamellar with predominantly longitudinally oriented primary vascular canals and primary osteons. An increase in primary canal number and/or size along the medial cortex is observed. Adolescents have lamellar primary periosteal cortex, typified by primary vascular canals and occasionally some primary osteons. Intracortical regions of endosteal origin are largely secondarily remodeled, while regions of periosteal origin contain fewer Haversian systems. As in children, bone microstructure also changes in adults. Now the changes are more related to bone remodeling activity, characterized through evaluation of osteon population density, or OPD, number of primary vascular canals, amount of unremodeled lamellar bone, percent of remodeled bone, and the average size of secondary osteons or Haversian canal. Once evaluation of various bone characteristics is defined, age at death can be calculated. For the calculation of the age at death, numerous regression equations exist. They differ based on the skeletal element used, but majority is applicable to the long bones or ribs. They also differ on the bone characteristics included. Also important to know is that the result is not a number, but an age range, though narrower than based solely on the macroscopic methods. Here we see examples of human bones and changes in their structure due to aging. Besides the thickening of the cortex, appearance of secondary osteons and increase in their number and density can be seen.